I thought I'm the only one here, but okay. So I'm Nikolay, and I work with Postgres over a decade already, and I built several startups which use it heavily, and it allows them to scale. And I'm not going to advertise Postgres for you. Peter already did it a lot with announcement that Percona starting support for Postgres. I'm going to talk how to make your database work more automated and effective. If you go to Hacker News, I'm sure most of you know this good place to discuss technologies. There is a thread, each month they public thread, who is hiring. So it contains a lot of, it contains a lot of job postings, and Postgres mentioned a lot there, but word DBA isn't mentioned there. So this shows that among startups, database administrator profession almost disappeared. And why? First of all, thank you. First of all, it's because of clouds and DevOps technologies. So when a team of engineers starts a new project, they feel that they don't need DBA because they can solve many issues themselves. So what is already automated? Instance provisioning, set up replicas, automated backups. In some cases, automated failover is already also automated in cloud providers like RDS. And only basic monitoring. When you need to scale and optimize your performance of your system, you again need database expertise. And this is my final, ultimate goal, to add new solutions which will allow you to automate optimization. So I'm working on the right part of this slide. Inside Postgres only world. I started from very, very first small step. I started to analyze my activity and activity of my colleagues when they analyze performance bottlenecks, find them, and prevent and optimize them. So I collected many useful scripts and put it to this project. It's called Postgres DBA. It is very, very easy to install, and it allows you to get a menu right inside Postgres console. So you just type :DBA and see these scripts. These scripts allow you to quickly understand what is the health of your database. Many things are not included in most monitoring systems. So actually, Postgres DBA usually copy-paste useful script to console and understands things which are not shown in monitoring. And it is very easily to extend. You can put your own reports there just with single line of code. But what next? This tool is cool and it's very, very simple, but actually it doesn't automate things, and it's still for experts. I see my final ultimate goal of database optimization is automation is not only detect bottlenecks but also prevent them. For example, if experienced DBA sees that developer missed index on a column, this DBA doesn't need to wait until data comes. It's obvious for him from his past experience that index should be created there. So also, in some cases, it's very difficult to understand what is the best index type in Postgres, or what is the best Postgres settings in Postgres config. And to find better better solutions, you need to do a lot of experiments. You can build a good automated pipeline which allows you to conduct experiments and find better parameters just with open source tools listed here. If you want to understand more, come tomorrow and hear my talk at 11 a.m. We will go to details. This is like funny slide with robots. So I see like I'm building 3 robots, artificial DBAs. Each one is in different topic, expert is in different topic, and they communicate with each other and with human. Thank you.
Good morning. So my name is Sugu. I'll be, thank you. I'll be talking about Vitess and a project that I've been super excited about. Next slide. Okay. Cool. So I did not exchange notes with Peter before, but I'm surprised at the coincidence and the number of trends that both him and I have in common in terms of seeing what's happening in the industry. Among the trends that he talked about, these are the ones that Vitess addresses of things that are happening in the data industry. One is transactional data is exploding. I mean, data itself is exploding, but most people have tried to keep that away from transactional data. But now that trend has caught up to people that are running databases. Now it's beginning to affect everyone. Like 8 years ago when we started Vitess, it was just, we thought it would be just companies like YouTube and Facebook facing this data explosion in relational databases. But now we are seeing small and medium businesses easily outgrow the size of a single database instance. And that is now, I think it's a problem that's pretty much caught up to everyone. And Vitess is trying to address that problem. The other trend, obviously, is the move to the cloud. And what I'm noticing is that databases are kind of lagging behind in this trend. Applications are moving much faster. People are more hesitant about moving database to the cloud. And this is something that Vitess will definitely help. And I'll show you some case studies about this. And the third one is the other one that's been people talking about is DBAs are redefining themselves. They are beginning to take on some of the SRE roles are becoming hybrid engineers. They are now rebranding themselves as DBEs or database engineers. And this is a change that Vitess is compatible with. So what does Vitess do? Essentially, Vitess is a sharding middleware. And the unique thing about Vitess is instead of reinventing the wheel from the ground up, it leverages what is already awesome, which is MySQL. So what it means to you is that if you are running a MySQL database and you are suddenly at capacity and need to grow, all you need to do is deploy Vitess on top and reshard underneath. And Vitess takes away the pain of sharding away from the application. So in other words, you don't have to do a complete rewrite if you have to reshard your data. The middleware will make sure that most of your queries will work as is, just like they used to work before. And all you still have to deal with the fact that you have now distributed your data and that it's there in more than one place. So some queries may have to be rewritten by the fact that data has to be fetched from multiple places, so they may not work like before. But mostly, it's a very low impact job to migrate to Vitess. I would say like 90 to 95% of your queries will work as is. And resharding is not a one-time thing. After you shard, the next thing that you have to do is within 6 months, you have to reshard. So that is another pain that Vitess takes away from you. You can reshard completely transparently with no change in the application and no downtime at all. So that is something that has been proven and done multiple times. And the other thing that is the big innovation in Vitess is the sharding scheme. It actually separates out the sharding engine from the sharding scheme and provides a formal interface between the two. This is actually stuff that is inspired by Michael Stonebreaker's work back in the 1990s. I don't know if many of you, you might have heard of a company called Illustra that was acquired by Informix. I was there when it happened. So this idea is actually inspired from that, and it's actually worked out pretty well. And obviously, Vitess is cloud-ready and has some awesome observability features. And this is actually, all these things coming together have actually inspired the industry to actually adopt Vitess pretty extensively. There's a lot of momentum now behind. There's actually many more companies that are currently on this slide that are checking Vitess out. A few companies that I wanted to point out is JD.com, HubSpot, and Stitch Labs. Those three companies have been running on Kubernetes using Vitess for a few years now. So especially Stitch Labs has been running on Kubernetes for a while. And they've been running at massive scale, very high QPS, and very reliably. So it is now proven that you can run MySQL in containers reliably and at massive scale. So that is one thing. And you also notice that it's not just the usual suspects that are beginning to use Vitess. There are actually much smaller companies, which is evidence that data is actually exploding and affecting everyone. So in conclusion, what I would say is do not fear putting data in MySQL because we believe scalability is a solved problem. In fact, if you have moved data out of MySQL because you couldn't scale, it's time to bring it back because we can help you scale. And do not fear running in the cloud. These companies have paved the way for us, and we know how to make that work. And there are some Vitess sessions that you can check out. There's sessions from Slack, both from an engineer point of view and a DBA point of view. And I'm also giving a talk on observability, which actually takes away many of the fears that Vitess operators have. And it will show you how easy it is to deploy and run Vitess. And thank you very much. I'll see you out there.
Cloud is a big deal. That like cloud database as services is a big deal. When you try to actually move your data into these databases that you don't actually control, you find that there's some issues with the existing tools. For example, in the cloud with databases and services, you usually do not have access to file systems. And without the file system, you can't use Percona Extra Backup. And without using Percona Extra Backup, you have to use MySQL dump. Now, if you have a large and busy data set, as we have alluded to already that many people have this problem, with MySQL dump, you will have a negative performance penalty on the source database as you run it, which could cause you to slow down your application or take it down completely, which is probably not acceptable for a lot of use cases. Another thing that we have kind of issues with is replication. In the clouds, usually the providers don't necessarily expose the MySQL replication interface directly to you. They usually have some sort of wrapper on top of it. The thing about these wrappers is that sometimes they will only offer a subset of what MySQL kind of allows you to do. So for example, and a provider might only allow you to replicate with GTID-based replication through their proprietary interface, and another cloud provider that maybe you have data on doesn't provide you with GTID replication at all. So then you have this situation where you can't set up replication between these two providers, and you're stuck, right? So without replication, you can't synchronize the data. Without being able to synchronize the data, then you have to stop writes to the source database to ensure data consistency. And stopping writes is, again, maybe unacceptable for your use cases. So unrelated to the cloud and the downtime in general is that sometimes you don't necessarily want to move like a whole database. Maybe you want to move a subset of the database. Maybe you want to move a subset of a table subject to a where constraint. And existing tools, while MySQL dump, something like that, can do that. MySQL replication does not allow you to filter on a per row basis. And this is problematic if you want to only move a subset, which has some applications inside the context of sharding, depending on how you perform your sharding strategy. And lastly, the existing tools all have this kind of drawback where it's just a bunch of tools and a bunch of command line options and flags that you have to know. And I, off the top of my head, cannot tell you how to migrate a data set from one place to another, just like with the existing tools off the top of my head. And if you're not a DBA and just an application owner, this might be a very daunting process for you. So that's another drawback of the existing tools. So in response to kind of all the problems that I just discussed, we created Ghostferry. Ghostferry provides a single binary solution that allows you to move data from one place to another with a single command. In addition to being a command line application, it is also a library, a Go library specifically. So you can build custom migration flows and customize it as much as you want to be able to filter for arbitrary data or even change data on the fly, like anything you want really. So it's very flexible in that sense. At Shopify, we have deployed Ghostferry into production, and we have moved well over 70 terabytes of data at this point using it, and that kind of proves the reliability of the tool. And we're also very confident in the underlying algorithm's correctness, as we have used formal methods to model the algorithm and understood it and found bugs and fixed it before we even wrote a single line of code. So we're very confident in its correctness. And as of today, the tool is also open source under the MIT license under the URL there. And I will be talking about it more later. So if you want to learn more about it later, you can come to my talk later today at 4:50 in room G, or browse the code on GitHub that we posted. And that is all I have to say about Ghostferry.
Or they've built a perpetual motion machine. If you're mathematics, you get emails that say that you know how to prove Fermat's last theorem, although that was proven a few years ago, so maybe less so now. And then, of course, in computer science, what's the crackpot email we get? Anybody? P equals NP, right? So even I don't do theory, I don't do algorithms. Even I get emails with people who have crazy ideas in the context of databases that say that they've been able to prove that P equals NP. So I got this email a few years ago that says they have a magical database that can do anything in constant time, right? They can sort data in constant time, which we know is not true. So the way I've been tracking my success as a new professor is over the years, just keeping track of every single crazy email that I get, right? And so you start off getting none, and then over time it gets better and better. And then what happened was in 2016, I had this inflection point where we started getting way more crazy emails. And this is because we started publishing and doing research in the context of using artificial intelligence and machine learning to automate a lot of the DBA processes, right? So this example here, this person tells me they can build the Terminator of databases, right? But then something happened last year where you see now this point where all of a sudden the number of crazy emails just dropped precipitously. And turned out what happened here was this is when Oracle announced that they've built the world's first self-driving database system. So I guess now all the crazy people are emailing Larry Ellison instead of emailing me. So you may be thinking that this is just sort of a marketing term, right? Some asshole came up with this idea and to capture the buzz on self-driving cars and apply it to databases. And so what I'll say is that, yes, it's very similar to what research we've done in the past on autonomous systems. It's just been called different things. So in the 1970s, when the first databases came out, this is called self-adaptive systems. In the 1990s, they were called self-tuning systems. And now we're just calling this self-driving systems. So you would be sort of half correct thinking it was an asshole that came up with this term, right, because it was me. But what I'll say is that self-driving systems are actually different than what this earlier work does for two key reasons. So all of this earlier work tried to solve this first problem here of what to change, right? What indexes to add, what knobs to tune, how to do materialized views. But what these older things do, but the newer systems are going to try to do, is figure out when to actually apply these changes, right? Know what the workload looks like and know when it's the right time to do maintenance. And then the hardest part of all of this is that when you apply a change, how do you actually determine whether that was a good idea, right? Are you actually getting a real benefit from this? And the reason why this is hard, because the hardware can change, the workload can change, your application can change. You don't know whether the index that you added in the past is actually helping you in your workload in the future, or whether just the workload itself has changed. So I'll talk more about this in my talk today at 11:30, and I'll cover, again, more background on what self-driving database systems look like, and I'll talk about some research projects we've been doing in this area. Okay, thank you.